But there might be a subject that's identified and dereferenceable on that website, like objective. And so when I HTTP get schema.omb.gov/objective, I'm going to get some data back, and within that data package, I'm going to have some predicates, like quantifies, and some objects that it points to, like goal. So different organizations create vocabularies that they use. They publish them on the web, and it's dereferenceable so that other people might use them, like HHS, the example below. So HHS has this objective called meaningful use. They might publish this on Data.hhs.gov/meaningful use. And when you dereference that information resource, you're going to get some triples that might demonstrate vocabulary reuse. So just as we have in XML and RDF, we also use a lot of namespaces. So here's an example when we dereference meaningful use. We know that it is a type of objective, and we can see that that type of objective is defined in an OMB namespace. And we know that it quantifies another dereferenceable object on data.hhs.gov, which is EHR exchange. Right? So this is the way that you would actually put this data up on the web using these vocabularies and expressing this data. So a site like Data.gov then becomes an aggregator. Right? It's a analytics center. So all the open data that's published in this way is easily queryable at the source at each data.agency.gov site. Or we might be able to ingest all of that data for more, let's say, application-intensive processing. And that's the kind of thing that we're doing with the Sparkle endpoint, the underlying RDF store, sometimes called a triple store, that is Virtuoso, that we're using on Data.gov now. So anybody, an application designer, a mashup creator, can go out there and query this universe of federated data and integrate it. And one of the virtues of RDF is that it's schemaless, right? So all of our domains, whether they're common vocabularies like management vocabulary, or domain-specific vocabularies like IT portfolio management or capital planning, all of the metadata and the instance data has the same shape. And that means that when we persist it or store it, we can use exactly the same tools. We don't need to create custom schemas. And therefore, we have a lot more flexibility and agility in terms of the domains that we can integrate. From an application developer's perspective, if I have some code that manipulates triples, that same code will manipulate any triples in any domain. So I don't even need custom APIs, right? The Web 2.0 world is obsessed with APIs. And what the Web of Data is saying is that it's the web. It's HTTP, which allows me to get this data, and Sparkle, which allows me to query that data. And I don't really need to develop my own custom get methods or set methods or any of that stuff that we typically do. Most often abused by SOA guys like me. That's the kind of thing we like to do, is design verbs, right? We don't need to do that on the Web of Data. It's a universal API for all the government data. So I've touched on a little bit of this. Common vocabularies, things like how do we express a catalog of data, or how do we express licenses for that data, or how do we express publishing information or provenance. These sorts of things we want to be standardized with voluntary consensus standards organizations. But for our mission-oriented data, we want the agencies to be the authoritative source of that vocabulary and how it evolves. And we can intermix and use that as we need to. And another really nice thing is that we can all do this independently, right? So someone might be an authoritative source for a management vocabulary and someone else for a capital planning vocabulary, and yet another third party can come along and interlink those in ways that helps us connect one domain to the other without necessarily having to change or even interact with the owners and the operators of these other vocabularies. That's a really powerful integration idea on the Web of Data. So lowering the coordination cost is the kind of thing that people like Clay Shirky and Web 2.0 advocates talk about a lot. And that's readily achieved with this kind of approach. So this is even worse as a geeky slide here. But what we're looking at is an IDE, an editor for a vocabulary. And so it has classes on the left and properties on the right. And this is the kind of thing, what's shown in this particular thing, if you want to look at it closely later, is exactly this kind of third-party interlinking vocabulary, where I can pull down from the web, since it's HTTP dereferenceable, I can actually get the definition of objective, and I can get the instance data of meaningful use, and I can create my own concepts and subclass them, or subclass the properties of the vocabularies that I'm trying to link. And then I can create properties, which are just relationships from one entity to another entity, and publish that on my website. Right? So that's what this is shown here. This is really the key. On the web, the value proposition, just ask Google. It's all about links, right? So on the data web, it's the same value proposition. You just extended how we can link using these technologies. So this is showing the same thing, the class model. This basically says that this concept here, federal agency, is not something that was defined in this management vocabulary. It defined a thing called organizational unit. So I defined a thing called federal agency, which is a subclass of organizational unit. So this is a way in which we can, and over here, we have an Exhibit 300, an Exhibit 53. These are also things that are defined elsewhere, but I can create properties that link an organizational unit to their IT portfolio. Right? So this is a little bit more of a close-up that's possibly easier to look at. And we see here some graphic representations of subject, predicate, object across domains. So on the left here we see the capital planning domain, Exhibit 353. And on the right we see this management domain, two independent vocabularies. And in the middle is the interlinking property that this third party created that links these two domains. So subject, predicate, object, and Exhibit 300 is the domain, the class of things, where you can use this property, supports a federal agency goal, which points to some object which will be an instance of a goal. That's the way in which you design these kind of data models. Right? So again, the most important idea here is that this can all happen independently. It doesn't have to be we all get together and define, I'll pick on the person object or something like that. Right? We can interlink these domains even if we have multiple meanings and multiple usages in context for person. Okay, so stuff is a little more fun. Certainly not something that we've, so those are the things we're engaged in the Data.gov PMO now. It's about vocabularies, standard vocabularies, domain-specific vocabularies, and URI schemes. That's the work that we're currently doing. Where we'd like to go is how we might exploit social media and social networking software to help us do that stuff. So I'll give you some examples of sites that are doing this and tools that facilitate this kind of thing. Freebase is a really popular site on the data web. In that original linked data cloud graphic, Freebase is in the center of it. There's a lot of data linked to and from Freebase. So on Freebase you create bases. You can create your own database, and you can interlink that with anything else on the data web. So this top part here is a screenshot from Freebase, and it shows a type specification of a particular ontology. So this ontology is called BISMO, short for business model. And the type that we're looking at here is goal. And so when we're looking at this human-readable representation, this HTML page, we see the properties that goal has. These are the predicates.